Today we're going to be talking about the extreme value theorem. Now, an extreme value on a graph, for example, the smallest point on the graph is called the absolute minimum, and the biggest point on a graph is called the absolute max. Now remember, we can have relative min and max. This is a relative min, and this is a relative max. In that case, relative min is the smallest point around its immediate surroundings. Same for relative max. It's the biggest point around its immediate surroundings. Let's take a look at some examples. This would be an absolute max. It's the tallest point on the graph, and this would be an absolute minimum. Okay, they would actually also be relative min and relative max. All right, let's look at this graph. This is an absolute max. These two share the distinguished categorization of absolute min. They're both the lowest point on the graph. Okay. What is an extreme value theorem? Let's go ahead and read that. A continuous function f of x on a closed interval ab. Closed interval is important. Okay, it means that it includes a and b with these brackets. It takes on both an absolute minimum and an absolute maximum value. So let's read that again. It has to be continuous, and it has to be on a closed interval. If it's on an open interval, like parentheses, it might not necessarily be true, and that has to do with asymptotes and infinity. Okay, in the case of f of x equals c, the max equals the min, and I wanted to point that out because if you have like y equals 3, technically every point on this graph is both the lowest and the highest, and so technically it is true. That's just kind of a special case. Most of the time we know that a function isn't a constant function like f of x equals c. In other words, since the function is bounded and continuous, no break in the rope, as we talked about continuity, then its function f of x values must be limited. And it makes sense. If it's a closed interval and it's continuous, it has to take on a biggest value and a smallest value. So it's kind of common sense. Let's take a look at some examples where it wouldn't apply. If we look at this function, I believe this is 1 over x or some variation. We do have a closed interval. It's from negative 4.5 to 4.5, but it's not continuous at x equals 0. And because of that, it actually doesn't take on a biggest value. It's going to go up forever here. It's not going to take on a smallest value. So extreme value theorem doesn't apply here because it's not continuous at 0 on the closed interval. All right, let's take a look. This example. This is also from negative 4.5 to 4.5, but we have a hole at 0. What would happen here is the y value would get closer and closer to 4 but never get there, and therefore it wouldn't actually have an absolute max. Now, it would have an absolute min. It'd be at negative 1, but it wouldn't have an absolute max. So the extreme value theorem would not apply here because it's not continuous there. All right. Let's take a look at this interval. Well, this goes from negative 4.5 to 4.5, but it's an open interval. There's a hole here and an asymptote here. There's no solid point, so it's not a closed interval, and since it's an open interval, we can see it's not going to take on an absolute minimum. It'll get closer and closer to negative 2.5 but never actually get there, and it's certainly not going to take an absolute max. It's going to keep going on forever as it approaches 4.5. These are all situations where the extreme value theorem doesn't apply. So again, make sure it is a closed interval and make sure it's continuous. As long as that's true, it's going to take on an absolute minimum and an absolute max. So let's go ahead and do some examples. Does the function f of x equal 1 over x have an absolute maximum on the interval 0 to 5? Well, we've already written the answer no, but let's actually talk about why that is. Well, it is a closed interval, so it seems like it should work, right? The function is not continuous at x equals 0. If we plug in 0 here for x, we get 1 over 0, which is undefined. Therefore, the extreme value theorem does not guarantee an absolute maximum on this interval. Okay, so it's not continuous on 0 to 5 because at 0, 1 over 0 equals undefined. And we can just write that out, equals undefined. So therefore, it's not continuous, and therefore, it's not going to work. Here's the function, and we can see at 0, even though the interval is closed, 0 then would be part of the interval, and it's not continuous there. So it does not take on an absolute max. It does take on an absolute min, whatever that value at 5 would be. I guess it would be 1/5 of 0.2. All right, does this function 1 over x have an absolute maximum on the interval 1 to 5. So we've changed the 0 to 1 now. And you can probably already tell what the answer is going to be here. Since the function is continuous on the closed interval 1, 5, then the extreme value theorem guarantees an absolute max on this interval. Well, how do we know it's continuous? Well, for 1 over x, you're really only concerned about 0. So from 1 to 5, you can plug in any number into x and get a number back. So it is continuous. And because the interval is closed, then that ensures an absolute max and min. And we can see that the absolute max here would be 1, min would be 0.2. That's pretty much it, folks. It's a pretty simple theorem. All you have to do is show that it's continuous on the interval and that the interval is closed. Note a couple things. The extreme value theorem is an existence theorem. It does not guarantee that the absolute extremes can be found. It just guarantees that they exist, and that's why it's called an existence theorem. So you might want to underline or highlight that in your notes. Next, the extreme value theorem does not involve derivatives. We will learn the mean value theorem, which involves derivatives, but both the extreme value theorem, which is what we're looking at today, and the intermediate value theorem actually doesn't involve derivatives at all. So that's pretty interesting to note that in case you want to keep that straight in your mind as you learn these different theorems for calculus, because we will be learning several. Okay, that's it for the extreme value theorem. If you have any other questions about this, let me know.